Thank you, everybody, and welcome to the Vector Search Conference 2025. Really glad to be here, and I hope all of you are having a great conference. So, the title of this talk that I'm presenting is on obviously vector databases, like you know, right? Because we are speaking at VectorCon. But the idea is enterprise grade vector database deployments. What are some of the strategies based on selection and scaling, right? So, a brief introduction about me. So, I currently lead the platform pre-sales at a Big Four consulting enterprise. I have roughly 14 plus years of experience, and I have been managing AI products and platforms for, let's say, roughly 2 to 3 years now. I am part of the CNCF Platforms Working Group. I'm a platform engineering ambassador, and I'm a DevOps Institute ambassador as well. Before we move forward, just a disclaimer that these are basically my personal views. I'm not representing my company, any enterprise, nothing. This is personally all my view based on my understanding, based on the work that I have done on this field. So the agenda is very simple. Okay, it's not very complicated, right? I wanted to keep things extremely simple. So we'll set some context on why do we as an enterprise need to think about what are some of the criteria or metrics to choose vector database. Why do we need that? Some context setting, right? What is the business context of doing something, right? Why are we even spending the time in talking about this? Why are you as listeners spending the time in listening about this? Then we move on to section 2, just a very high level thought process on vector databases. And this is where we focus also on some of the key criteria that we have seen, that I have seen works well, right? Now, some are very common criteria that everybody knows about, and then some could be a little bit nuanced criteria that maybe you have not heard about before this talk, which would be interesting. Then section 3 is how do we scale? As you understand, right? How do we scale these vector databases, the components that we have chosen across an enterprise? So I'm part of an enterprise where we have 450,000 people, right? So how are we thinking about scaling AI products, especially vector databases? And finally, some closing thoughts to end the talk. Without further ado, let's get started with some context setting. So this is a survey from Redgate, and one of the things that you might have understood already, right, is that we already in enterprises have a large number of database platforms. The modern data landscape, even without vector databases, even without AI applications, is extremely complicated. So if you see in 2024, we roughly have 74% of the companies which is at least two or more data platforms, right? At least two or more, right? Which is okay. I think two or more is okay. But then when we kind of move on, now you see that we are actually having more and more sort of data platforms over time. Again, some might change a little bit, but if you kind of see the trend, right, and see the average, right, you will see that we have roughly in 2024, roughly 47% of the products or companies who have 2 to 3 data platforms. 17% has 4 to 5, 9% which is more than 5, right? So obviously, right, it is only 26% of the employees just has one data platform or database or whatever we call it, right? So again, I'm taking this as a proxy for the overall data estate, not just a typical database system. Because anybody like us, right, who have been in the enterprise industry for a long time, we know, right, this is the truth, right? We have seen so many different types of databases: NoSQL, SQL, graph databases, now vector databases. Why? So why are so many different types of data providers or vendors? Why are enterprises choosing so many times? Mostly because, as you can see, the most major reason is they feel, as we as enterprises feel, that different data platforms have different needs that they can meet. So the need that I can meet from a graph database is not the same that I can meet from a traditional relational database. That is what is kind of forcing us, right, to go across the spectrum, right? We will have some relational database, we will have some NoSQL databases, we will have some graph databases, and now the new kid in the block, some vector databases as well. If you see, this analyst report also shows the same thing, right? There are so many different reasons, right? So basically what is happening, if you see, because of so many different sort of data platforms, now there is some tension in the system also, right? What do I mean by tension is, let's say I have some data in my relational database, and I'm keeping some data in my vector database. How do I sync them? right? How do I ensure that all of the databases have a common ontology, for example? How do I have a common data, metadata? How do I know which data can be trusted, which is the traditional data governance challenge, right? So there's a lot of concern already in the enterprise. Even without vector databases, we have a lot of data platforms in the enterprise, and this large number of data platforms have essentially led to this sort of different sort of challenges that a chief data officer is grappling with. So obviously you can understand, right, that when we now introduce an enterprise to this concept of this vector database, which is a new type of database we are saying will work very well with GenAI applications, they are a little concerned, right? Like what do I choose? Why cannot I use something which was already available? What do I have to choose? Do I choose an extension of the existing database? Do I go with a new vendor? And this becomes all the more challenging if you see the current landscape that we have in the vector database industry, right? We have so many vector databases, right? It's like a new company, a new startup is just coming up every day. So if you sum it up all, right, already even before vector databases were there, we were under a little bit of pressure as an enterprise with so lot of data, so many different data platforms, right? SQL, NoSQL, graph data platforms, cloud-based data platforms, specialized data lakes, warehouses, Databricks, Snowflake, DuckDB, no matter what, right? And all of that was leading to a lot of challenges in the system, right? Data duplication, data isolation, metadata management, data cataloging, right? Now, on top of that, we have this new thing called vector database. And it's not just one or two databases. We have a zillion databases, right? As you can see some right at Pinecone, Quadrant, VV8, Chroma, right? Phase. All of them are good databases, right? That everybody has its own pros and cons and all of that. So it's very concerning at an enterprise level. And I can speak for some of the concerns that we had in our enterprise as well is what do we do about this space, right? How do we control it? How do we govern it? How do I know should I use A versus B? When should I use Milvus versus when should I use Chroma? Or when should I use just a PG vector, right, from a PostgreSQL database? Can I use the SQL vector offerings that is available today? What should I do? So this is basically the section one, right? When I wanted to set some context on why all of these topics that we are trying to discuss is interesting. So the key takeaway message would be that there is already a lot of complexity in the data estate of an enterprise. With specialized vector databases just for storing embeddings, right? Vector databases for GenAI applications, the complexity is again rising, right? And now there are so many vector database vendors that enterprises are struggling to understand how they manage this state. How can they kind of understand what to choose when? How can they get rid of some of the complexity? How can they kind of introduce some sort of standardization and generalization? Perfect. So again, it's a VectorCon search, VectorCon conference. So we should at least high level, right, discuss what is a vector database. Obviously, I think all of the attendees here already know what is a vector database, but these are a different type of database to some extent, right? Again, some things are same, some things are different. That specifically kind of designed to store, index, and search high dimensional vector embeddings. So what are these vector embeddings? Typically, the vector embeddings are generated from unstructured data, text, images, right? Something like that. And they're generated using machine learning models, basically. And the cool thing about these vector embeddings is that two embeddings will always be kind of similar if they represent similar words, basically. So for example, if I create a vector embedding of a dog and I create a vector embedding of a cat, they will be different. But the moment I create a vector embedding of the word puppy, you will see in the vector space that the vector embedding entry or the coordinate of puppy is quite in the same place as it is with dog, right? So that's how that embedding goes through. And there are a lot of nice embedding models, for example, OpenAI ADA model. There are many more, right? And again, this is a lot of complexity in itself. And if you see, with so many vector databases, so vector embeddings that we are creating, you need to store them somewhere, right? So that you can keep them somewhere and very fast you can search across them. So let's say I have created vector embeddings of 100, let's say, chunks or documents, for example, just to simplify it. Now I get a keyword. I want to very quickly know which chunk of the document that statement is available. So I need to be able to, again, very quickly search the vector database where I'm keeping this vector embeddings. Basically, these embeddings I'm keeping somewhere. Those things I have to very quickly search. That's why this new sort of a vector database sort of paradigm has emerged. And if you see, even though obviously it is relatively new, still, even though it's relatively new, it has taken roughly 2.5%, right, of the overall thought process, whereas graph database is only 1.6%. This is the asset of, this is a report from the dbengines.com site, very nice site, which kind of gives a lot of data on what database things are happening in the industry. But you can understand, right? So in the small time, if somebody has captured 2.7% of the scope of the overall market or interest, that means a big thing, right? And as I said, it is a specialized sort of a database, which is like for very high volume vector embedding, storing, indexing, retrieval. Also, I was telling you something, right, that there is a lot of people in this space, right? It's a crowded space, basically, right? So very recently, Retool did an analysis of all of the vector databases, some of the vector databases that developers like. And if you see Postgre, so PG Vector, very popular, open source enablement of the PostgreSQL open source database, right? So it has a percentage of 21.3%. MongoDB is also very popular, 21.1. Pinecone is specifically built for vector embeddings, 14.4. Chroma, 12.2. Elasticsearch, again, very good in search. Now they're also kind of moving into this vector space. So as you can see, there is a lot of vector offerings already, vector DB offerings, which are already available in the market. Now, some of them are like the existing database models like Postgre, Elastic, right? They were already available. Redis was a very well cached. They have now kind of used their same sort of structure, same engineering capabilities, and now they have kind of added this vector as a new sort of offering in their whole space. So that's then. And then you have, let's say, native, or let's call them GenAI native vector databases that have risen from the ground up, which is Quadrant, Weaviate, Milvus, Pinecone. This does not exist. They don't do relational databases. They never did search. These are companies that have been built from ground up just to serve vector embeddings for GenAI applications. And everybody has their own sort of positive and negative, and we will go through some of them. But as you can understand, right, that there is a lot, right? Postgre is obviously the winner based on this survey, but there is a lot of opportunity. So the complexity that arises is that there are so many options, right? What do I use? Should I use Pinecone? Should I use OpenSearch? Should I use Chroma? Should I use Quadrant, right? There is a lot of complexity. As an individual developer also, I will have complexity, but also at an enterprise level. And as you can understand, at enterprise, we need to do things which will scale, right? Because we need to do them again and again and again. So enterprises typically don't want a lot of options unless and until it's very, very needed, or for a very niche case. Normally, enterprises will try to, let's say, stick with one or two sort of stuff and kind of go at scale and repeat and create trusted boundaries around them, right? So for enterprises, it is even more important to understand what are some of these vector offerings or vector databases in the market that they should invest in. Should they allow developers to do whatever they want? One developer will do Chroma, another will do Quadrant, another will do Pinecone. But then who supports them once they go to production? What happens tomorrow if Pinecone goes out of business? What happens tomorrow if Quadrant has a issue? How are they going to give support? How do I manage all of those vendors? What happens if there is a legal challenge in some of these vendors, right? And I cannot work with them again, right? What is the scope? So doing a POC on your laptop using LangChain and Quadrant is one thing, but when you're thinking from an enterprise level, there is a lot of things that we need to think of, especially because there is so much option in the market today. So already, if you just do a very simple Google search saying which vector database should I choose, you will see a lot of frameworks, let's say criterias are kind of emerging. Everybody has their point of view. Not only the vector database providers, obviously vector database providers are putting out stuff in the market which is, let's say, favoring their vector database over others, but then there are a lot of independent voices out in the industry who are also trying to do a very, very good job of coming up with an evaluation framework. So for example, if you see this one, this is a very simple framework that I found, which is basically saying that what are some of the things that an enterprise grade vector database should have from perspective of two perspectives. So one perspective they're focusing is on developer experience. Now, how easy it is for developers to use. Does it have good documentation? Does it have good library support? Does it have a good SDK? Is it easy to use? Is there a good community behind it? Does the GitHub repo, for example, if it is open source, has a lot of stars? So one aspect we should always have when we are working with something like a database, whether it's a vector database, relational database, whether it's a NoSQL database, graph database, is the developer experience. Because at the end of the day, who is the consumer of the database? Not a business person. The actual consumer of the database is a developer or the database engineer, an AI engineer or a full stack engineer, whatever we call it, right? So from the lens of a developer experience, these are some of the things that are relatively important, right? That are some things that you need to take care of. Do you have good documentation, good SDK? Is it easy to use? But at the same time, if you think from the overall construct of technology, you also need to think, right, okay, is it the cost effective option? Is it the most cost effective option? Does it have enterprise grade security? Does it have enterprise grade support? Can it scale? Can it scale with millions of embeddings? How will it perform if I search one embedding from a million embeddings stored in the database? How will the vendor support me if, for example, I have a security vulnerability tomorrow in the base image, right? So all of these aspects is what is also equally important for an enterprise to think about. So obviously they need to think about the developer, how easy it is for the developer to use the vector database. But it is also very, very important for the enterprise level thought process, like how scalable it is, how rich, how supportive the vendor is, right? Is it the most cost effective option? Is it a secure option? Or am I kind of, because as an enterprise I will put my client's data, right, production grade data in here. So all of this. But this is, again, as I said, this is available in Google search. You go to Google and you get it. What I have not seen in Google that much, right, that much, but I feel they're also equally important, right? Because that's what we are feeling in our some of the work we are doing. So I've just focused on four aspects here, which I feel are very, very important, even though they're not mentioned in there and maybe not in the category of developer experience or technology experience directly, but equally important. One is the deployment methodology. So when we were reviewing vectors offerings from the market and vendors, one of the things is that, are the SaaS vendors, or do they support a model where you can deploy within your enterprise's network or boundary? This is very important because this is important data. We don't want this data to again go out of our company's network to another SaaS provider who is storing it in their data center or some Azure data center or something, right? Because the idea would be that, okay, I might go to SaaS for some of the ease of use and the subscription based model, which is okay for small POCs, startups, maybe even small projects. But for enterprise grade projects, I would want to keep the control with myself. So I need a vendor, maybe I will need it, right? If it is important for me, who can help me deploy it. They will manage it, they will provide the support patching, but they will deploy it within my network. So I will give them compute, storage, network. I will give them a VM, a subscription, or whatever. They will be able to deploy it and obviously provide support, right? But they will be at least be able to deploy it. So these two methodologies are very important. These two types of deployment methodologies, and I've seen there are some vendors who only support one. So most of this GenAI native, starting from scratch sort of vendors or vector providers, DB providers, you will see them, they're mostly comfortable with the SaaS sort of an option. They're not as good. Sometimes they might not even offer, and sometimes they might not be as good with the enterprise deployment sort of a methodology, right? So that is very important. I felt that as representing the best interest of our enterprise, we need to take care of this part. Second is the support model. So there's a lot of cool operating OSS, right? Open source software, vector offerings. Fives, for example, from Facebook is a very good example. But at an enterprise grade, do I really want OSS? Because people, right, open source is free as a puppy is free. That's a very well-known idiom. So again, we need to be very, very clear. Do we want to use an OSS, or do you want to use an enterprise grade offering which provides enterprise support? If I use an OSS, obviously I don't pay any license fee. I might get good community support, but what if tomorrow there is another Log4j? Who will patch the base image? We'll have to wait for the community to patch the base image. And we have suffered in some things like this, right? We have used an antivirus a long time back. I used to use an antivirus, which was an OSS antivirus. And when there was an issue, and when we raised a ticket in GitHub, because that's the maximum you can do, the answer was it will take 30 days maximum, which is not acceptable for an enterprise. So mostly we'll see enterprises will go with options which provide enterprise support, SLA. So that is also very important. Most of the Google articles on this topic doesn't mention this thing. They mention on the scalability, performance, all of that. Very important, I agree. But this is also equally and sometimes even more important. The third thing is vendor profiling. This is also very important for an enterprise. Whether the company that you are buying from, is it a startup or is it an enterprise grade company? Again, it's not a bad thing to be a startup, but how do you know whether the startup will be able to kind of survive? How do you know whether a bigger company will not buy the startup and then change the offering or make the offering more pricey, like what happened with VMware and Broadcom? How do you think about all of those things, right? So the overall thought process here should always be, to the extent we cannot predict the future, right? Nobody could predict what happened with VMware and Broadcom. Both of them are big companies. VMware itself was a big company, but the chances are higher with startups or some startups. Let's say it's a very, very new startup versus somebody who has been around for 10 to 15 years, for example, in the database space. So let's say they were in the search space, they were in the graph space, now they're coming up in the vector space. So very, very important to profile the vendor, startup versus enterprise grade. The fourth thing is education. It's very important for us to kind of not put more cognitive load on our developers, right? So if a developer is already very comfortable with Elasticsearch, let's say they have developed 10 applications with Elasticsearch, even if we feel that Elasticsearch might not be the best of the best, still, just because of the familiarity and the fact that our developers and our engineering community already knows about Elasticsearch, already knows how to work with that, if Elasticsearch also offers a vector offering as part of its suite, it might be a good choice as well, because our engineers are already familiar with it. The education curve, the learning curve is much less, right? So as I said, right, these are some of the aspects which are very, very important that we have felt, right, that I have felt when I have worked on. Obviously, there are many other aspects, as I showed you some of them: the ease of use, the SDK support, tooling support, programming language support, scalability, performance, security. I'm not doubting any of them, but I wanted to kind of call out this four because in most of the articles in the internet, you don't see this, because most of the articles on the internet are coming from the thought process of, okay, I'm doing a POC, what is the best? I'm doing a high value trading thing, what is the best, right? But we also need to think from an enterprise angle. That's what I'm trying to get to here. In the end, everything, no matter what is the criteria, you set the criteria for your enterprise. You take guidance from me, you take guidance from many other people, but the criteria for your enterprise has to be set by you. You have to experiment, strategize, and evaluate, and finally choose a vector database that works for you and for your use case. That is the most important thing. So the key takeaway message here is that knowing why and when to choose a vector offering is very important for an enterprise. And when choosing that, they need to set up all of the criteria, prioritize it based on their needs, based on what they think are important for that particular enterprise. It might not be the same across all enterprises. There are some good evaluation framework that is already available, as I showed you, out in the market. You can use it, and also think from an enterprise angle. Just don't think from a startup angle. A platform-centric approach, this is the last important section. After that, there is closing thoughts. So there is concept in this industry called platform engineering. So a platform is nothing but an internal technology platform that provides an offering that the rest of the enterprise can consume self-service. So if I need an observability, if I need observability or logging for my application, I should not build it myself, right? I should just go to some central platform. The platform team is building it, managing it, maintaining it, everything. I should just go to some sort of a marketplace, consume or adopt that offering, buy that offering from that internal platform marketplace and use it. So this is the overall concept of a platform. This kind of shows it in a good way. As you can see, we have an infrastructure platform, then you have some reusable components and tools and services that you build on top of the infrastructure platform. This is the digital platform. You have some sort of a developer portal, some sort of a marketplace or a portal that people can use, the developers in your company can use to adopt that offering. This is another view. This is another view which kind of shows the platforming. As you can see, these are the application developers and they communicate with the platform engineering team. So the platform engineering team is a central team who manages those offerings, and then you have application developers who are building business facing products who are consuming stuff from the platform engineering team. Again, another view. As you can see, these are the different product teams. Those product teams are going to consume offerings from the platform by APIs, via some self-service APIs, whatever is the possibility. But the idea is that there is a central platform that will manage the central technology assets. Individual product teams, business-facing product teams will not duplicate it, will not build it again and again. They will rather consume it from here. Also, platform engineering is not something that is, let's say, very, let's say something like quantum computing that will happen in another 5-10 years. No. If you see here, 55% of the organizations are already on board into platform engineering based on a survey that Google Cloud did, and 90% are planning to expand the adoption. So it's already kind of available. With this thought process, if your enterprise already has a platform or something like a platform, if you now want to scale the usage of the vector databases that you have chosen, so as I said, you have chosen a set of vector databases based on the criteria. You already have that list, right? Which you think is the best for your enterprise. Now, how do you scale its usage across the enterprise? You need to provide it as part of your central technology platform as a self-service offering. So if I'm a developer, I go to the platform marketplace, I go to this internal platform, I should see Pinecone Quadrant and Weaviate if my platform team has made them available. If as an enterprise, if I think these are the 3 variations of vector databases that is the best for my enterprise, I should obviously experiment and do all of that analysis. But once my due diligence is done, I should make it available as part of the marketplace. That is the only way to scale and standardize while scaling. Otherwise, if you don't do this, if you don't make it very easy to consume your preferred offerings, every single developer will start doing it their own thing. There will be chaos, there will be duplication. You will end up with 20, 30 vector provided TP providers in your company. Too many contracts, too many duplications, security vulnerabilities here and there. So this is what we are trying to enforce here, that whatever you choose based on section 2, the criteria that you have come up with, whatever you choose, those vector database offerings, whether it's Mongo, whether it is Elastic or Quadrant, you make them available, make them part of your central platform offering so that anybody can consume it. With this, I will come to some very simple closing thoughts. So based on an analysis that was done quite a while back, one of the thought processes is that up to 73% of a company data goes unused for AI or analytics. So the data problem was always there, even before AI came. It's just that with AI, somebody kind of put the torch on it, right? Kind of put the spotlight on it. So in a typical enterprise, up to 73% of the company data anyways goes unused, right? So on top of that, we also know that for good AI, we need good data, right? We know that, right? So we know that there is a lot of data that is getting unused, and at the same time, we need a strong data foundation, good governance, unified cataloging. It is fundamental to the success of my enterprise-wide AI initiative. To do that, as I said, right, this is all the reason why we are doing this. So we need as an enterprise to decide on what is the vector databases that we should support. We need to do that, right? Because we cannot have too much of different sort of stuff. We need to have one thing, and everybody should follow that standard. That is the only way we will have that governance, right? We will have that kind of shared metadata, shared way of working, shared way of storing embeddings, so that today I am accessing that embedding via one way, then tomorrow if somebody wants to access, they are also accessing it in the same way, because I only have 2 to 3 types of databases available. And finally, we need to make them part of this self-service offering, right? That is also very important. And basically, even more than self-service, part of this internal platform construct. Or we could just choose Postgre. This is just a meme. I wanted to end this talk on a light note, that either you try to select different vector databases, or you just end up using Postgre, because again, it's awesome. I also use it. So with this, I wanted to thank all of you, first of all, for listening to me, and also for attending the VectorCon 2025. I'm having a great time listening to all of the esteemed speakers, learning a lot, networking. I hope you also got something out of this session. See you all soon. Thank you.